This section is on trig functions of any angle, so we're getting outside of just the first revolution 0 to 2 pi. And so to introduce this, let's take a look at the unit circle, and this will also lead in towards graphing these trig values as functions, y is a function of x. So first of all, for sine, sine's a y value on the unit circle, so in quadrants 1 and 2, it's going to be positive. In quadrants 3 and 4, you'd expect it then to be negative. For cosine, cosine is an x value on the unit circle, so quadrants 1 and 4 it would be positive. Quadrants 2 and 3 it would be negative, being an x value. Tangent, you can think of as sine over cosine. You could also think of it as a slope, so tangent is positive first and third quadrants, positive slopes, negative second and fourth quadrants, negative slopes. For cosecant, secant, cotangent, just thinking of those as the reciprocals of sine, cosine, and tangent respectively, we can get the signs of those trig functions in the different quadrants. So if you find out which quadrant you're in, then you know what value you'll have. Now, domain for sine and cosine is all real numbers. No matter what angle you put in, you're somewhere in the unit circle, it's going to have an x and a y value, so that point. So domain's all real numbers. Because it is a unit circle, you can never get farther out than 1 this way or this way. So the range for cosine is negative 1 to 1. Likewise, range for sine is negative 1 to 1 because you can never get below negative 1 or above 1 since it's a unit circle, radius 1. Sine and cosine are going to repeat every 2 pi. Now, of course, there's symmetry in first and second quadrants for sine, for instance, but as far as an actual repeat of the entire sequence of angles, that happens once every revolution. So the period is 2 pi. It's the same for cosine, period is 2 pi. Now this is different for tangent. For tangent, you'll have, say, an angle up here. You'll have the same value down 180 degrees lower, pi. So, and then so you'll just repeat every half revolution. So the period for tangent is only pi. Dealing with the domain and range of tangent, the domain is everywhere except the top and bottom of the circle. You can't take a tangent up here or down here because it's vertical. You'd be divided by 0, cosine 0 at those points. So the domain is not pi over 2 plus k pi being multiples of pi. So these top and bottom places, but anywhere else is fine. The range is all real numbers because you can get slopes from 0, getting steeper and steeper and steeper, all the way up to infinity, and then negative infinity and back down to 0 as well. Now for say, skipping down to cotangent, cotangent being the reciprocal of tangent, the range will again be all real numbers. And as far as the domain, you can't have multiples of pi because if you have a spot, say over here, it's cosine over sine to get cotangent, and dividing by 0 for sine, you can't do that. So these two spots over here, which are multiples of pi, are outside the domain of cotangent. Once again, though the period for cotangent is pi, it repeats in the same way that tangent does. Cosecant and secant, the periods are 2 pi, just as they are for sine and cosine, since they're just reciprocals of sine and cosine. Here you see the domains for cosecant and secant. Basically, cosecant's everywhere except when sine is 0, so that's at multiples of pi. Secant's everywhere except for top and bottom, here where cosine is 0. And for the range for these two, that's written down here in interval notation, or it's also written here, slightly different notation, but the range for both cosecant and secant is from negative infinity up to negative 1, including negative 1, and then from 1 to infinity, including 1, because if you think of the range of cosecant and secant as 1 divided by the range of sine and cosine, you can get 1 divided by the values between negative 1 and 1 are going to end up giving you these, but nothing in between. Now, once we get in towards graphing these things, we will see that sine is odd, cosine's even, and then from that we can get the fact that tangent and cotangent are odd, cosecant being 1 over sine is odd, and secant being 1 over cosine is even. That's going to help us a little bit with our graphing a little bit later. Now some sample problems. So first of all, taking a look at 2a. So we have this point 12, negative 5, so clearly it's not actually a unit circle, but we want to find the trig values of the angle there. So what we see is at this spot, 12 to the right, negative 5 down. We always make the hypotenuse positive, but we get that, of course, with the Pythagorean theorem. And then we just use SOHCAHTOA to read off the values. Sine is going to be opposite over hypotenuse. So that's negative 5/13. Cosine's adjacent over hypotenuse. positive 12/13. Tangent is opposite over adjacent, negative 5/12. And then for these three, they're just the reciprocals of the one to the left. So here's cosecant, here's secant, and here would be cotangent. Okay, for 14, find the quadrant in which theta lies. So secant's positive and cotangent is negative. All right, for secant to be positive, secant's like cosine. It's 1 over cosine, and 1 divided by a positive is positive. So for secant to be positive, you're in the blue quadrants. And for cotangent to be negative, you're going to be in the green quadrants. And so these overlap here in red in quadrant number 4. 16 is a similar idea, positive cotangent, positive cosine. So positive cotangent's first and third, positive cosine is first and fourth. And so let's try that again. Wait a minute. Positive cotangent first and third, and positive cosine. Yeah, positive cosine first and fourth. So that looks like it's going to be actually over in here, where cotangent and cosine are both positive, so not there. Okay, moving on. For number 20, find the values of the 6 trig functions for theta. Cosecant theta is 4, cotangent's negative. This is going to help us figure out which quadrant we're in, and then we can go from there. So cosecant's 4, cotangent's negative. All right, if cosecant's 4, then that tells us that we're in one of these two quadrants, because that's where cosecant's positive, and cotangent's negative, which means we must be in quadrant 2, because cotangent's negative in these two. So it overlaps in this quadrant. Now we have cosecant was 4. Cosecant is hypotenuse over opposite. Use the Pythagorean theorem to get the third side. And once we've done that, it's rad 15, but we'll make it negative rad 15 because it's going to the left. And now we just read off our values: opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, and then the reciprocals of all of these to get our other values. Okay. 70. Tan theta is negative 5/4. We're in quadrant 4, and we want to find cosecant. So what we do is we know which quadrant we're in, so we're going to go ahead and draw an angle in that quadrant. We put it in quadrant 4. And since tangent was negative 5/4, we can put a negative 5 here and a 4 there. Use the Pythagorean theorem to get rad 41, and we'll make it positive for the hypotenuse always. Cosecant's hypotenuse over opposite, so that's simply negative rad 41 over 5. Now for 90, this is getting towards solving trigonometric equations, but we'll look at it graphically. So we want to find places only from 0 to 360 and 0 to 2 pi. So we're not looking for general solutions, just specific solutions in the first revolution, where cosine theta is rad 2 over 2 and where it's negative rad 2 over 2. So cosine theta positive rad 2 over 2 will be at these two spots over here in the first and fourth quadrant, and that corresponds to 45 degrees or pi over 4. This one, 315 degrees or 7 pi over 4. Over here, cosine theta negative rad 2 over 2, it's these two spots. Cosine's an x value, so it's in the second and third quadrants. So that's 135 degrees or 3 pi over 4, and 225 degrees or 5 pi over 4. Similar idea in number 92, where we're trying to find places where cosecant theta is negative rad 2, which implies that sine theta is negative rad 2 over 2. Well, sine is negative in the third and fourth quadrants, right in the middle of the quadrants, so to speak. And so that's 225 degrees and 5 pi over 4, and 315 degrees and 7 pi over 4. When cosecant theta is equal to 2, 1 over cosecant is sine, so sine theta is a half, and that's part of the way up in first quadrant, part of the way up this direction in second quadrant. So that corresponds to 30 degrees and pi over 6, and 150 degrees and 5 pi over 6. And finally, looking at 101, we have f of theta is sine theta, g of theta is cosine theta, and we're just supposed to evaluate all of these without a calculator. And in 101, we have theta is 7 pi over 6. So it's just some practice with different trig values, making sure that you can find all of them. It's best to learn these as soon as possible and think of it graphically so you're not always getting hung up on it. So sine 7 pi over 6 plus cosine 7 pi over 6. Let's think about where we are graphically here. 7 pi over 6 is down about here. So at this spot, we have sine is going to be negative a half because we're a little way down. Cosine will also be negative because it's third quadrant, negative rad 3 over 2. And then we just put it together as a fraction. Here's cosine minus sine. If cosine squared of 7 pi over 6 was negative rad 3 over 2, where we square it, we get 3/4. And then sine of 7 pi over 6 times cosine of 7 pi over 6. We'll just multiply the two values that we get over here. And then the last couple, 2 times sine of 7 pi over 6. Sine of 7 pi over 6 was negative a half, so we get negative 1. Cosine of negative 7 pi over 6. Well, there's several different ways to do this, but one way to think about it is that cosine is an even function. So cosine of negative 7 pi over 6 will be the same as cosine of positive 7 pi over 6, which we know, of course, is negative rad 3 over 2.